the Linux kernel. In this nugget, we're going to continue our discussion of the Linux kernel. We'll learn how to customize a kernel, and then we'll go through the necessary steps to compile and install the kernel from source code. Now, if you're going to follow along with this nugget, you should allow a good bit of time, especially if you have an older processor. Because even though the video will only be 25 or 30 minutes long, I'm going to pause the video a number of times while the actual compiling is taking place. Alright, so let's get to it. Alright, so the process of configuring, compiling, and installing a custom kernel requires that we have the source code for the kernel on our system. Alright, but more than that, it requires that we have a set of tools available to us so that we can do this whole process. Okay, we need the kernel source code, but we also need some libraries, we need a C language compiler, and so on. And this is a list of the required RPMs, the packages that you have to have on your system so that you can follow along and do what I'm going to do in this nugget. Alright, so let's just go over what each of these things are. Kernel source, and notice I've written them as kernel source -star. So that's, the star is just representing the version number. So if you were going to check whether you have this particular package on your system, you could do like an RPM command. You could say RPM -q kernel source -star. And this will tell you whether you have the kernel source on your machine, and it will also come back and tell you what version it is. So it'll come back and say something like, kernel source, dash, 2.4.20-20 or something like that. Okay, and so the current version of the kernel source that you have on your machine will come back from the output of this RPM command. And you should do that for each of these elements here. glibc has to do with libraries for the kernel headers. This is a developmental or development C library. This has to do with a C language preprocessor. Binutils is a set of binary utilities that we're going to need available to us. GCC is the GNU C compiler. TCL and TK, these are both scripting languages that we need to run the particular configuration utility that I'm going to show you how to run in this nugget. Okay, so this is the set of RPMs that you need installed in your system, and now what we'll do is we'll go out to the Linux screen and we'll start the process of configuring, compiling, and installing our custom kernel. Now we're going to walk through the necessary steps to customize, compile, and install our customized kernel. Okay, so sometimes you'll see the process of compiling and installing a kernel called building a kernel. Same difference, different words, same meaning. Okay, you can see also here I'm working on the Nugget Rescue machine again. This was the machine I used for the Linux Rescue video a few videos ago, and I just moved to this machine because since I already upgraded the kernel on the Nugget machine, I didn't want to mess with that, and so I'm just moved over to this machine to do the customization here. Alright, so remember, now the first thing you have to make sure of when you're doing any of this customization of a kernel and so on is make sure you've got a boot disk with an emergency boot disk with your current kernel version on it. Okay, so you can always get in there, get into rescue mode and fix things if need be. Alright, so if you don't have that, remember the command from a couple from that Linux Rescue video again called make boot disk. Okay, so make sure you've got a current boot disk and you can make one with that command if you don't have one on hand already. Okay, and remember you've got to check for the various packages on your system, and here we're going to check to make sure we have the kernel source package. You can see I'm working with the kernel source 2.4.18-14. That's the same kernel that I'm running on this particular machine, on this Nugget Rescue machine. But whatever I do in this video, you can do on the 2.4.20 kernel or the 2.4.19 kernel or pretty much any other kernel at all. Okay, so if you go back too far, like 2.0 or 2.2 kernels, then you'll start to see differences in the interfaces and things like that. But if you'll be able to follow along perfectly well for any of the 2.4 kernels. Okay, so this is the kernel we're going to customize, and remember to check all those various RPMs that we talked about on the whiteboard just a couple minutes ago, and make sure all of those things are installed in your system. Now, once you get all those installed, actually, I'm going to switch over to be the super user here because you have to be the super user to do this process, and then go to the user source Linux 2.4 directory. All the rest of the commands that we execute in this video are going to be done from the user source Linux 2.4 directory. All right. Now, the first real step in customizing and building a kernel is you have to make sure that the source tree, so the part of the directory structure that holds all the source code, you have to make sure that that's in kind of a predictable state. Okay? And the way that you can do that is using the make command and say make mr proper. Okay? Now, the make command, really what it's doing is it's executing a script called a make file. And a make file just has separate sections in it, and you refer to those sections like mr proper is one of the sections in the make file that was created. Okay? And so what this is going to do is this is going to go through the source tree and make sure that, that everything's kind of in the right order to progress through the rest of this process. Okay, so this is going to do that for us. Now, one thing that you want to note before you execute this command is if you've already got a configuration that you like, say you've already configured this kernel once. Well, somewhere in this directory, you're going to have a file called .config, and you can see here I don't have that file .config because I didn't do any customization on this Nugget Rescue machine. Okay, but if you've done some customization, take that .config, and you want to use that customization again for your future kernel, take that .config file and save it somewhere else on the system. Don't save it as like .config.backup or something like that, because it's still going to be found and deleted by the make mr proper command. Okay, so take it and copy it to some other place on the system. Call it something different. Just keep track of where you're putting it so that you can copy it back later. Okay, so what we're going to do here is we're going to say make mr proper. Okay, and then it's going to scroll a bunch of stuff up the screen, basically what it's executing, and you can see all the stuff that it's doing here. It's deleting files and so on, and it's recursively going down a set of directories and so on. Okay, and now we're back to the prompt, and it's done its preliminary work to make sure the source tree is in good order. Okay, so let's just clear the screen so that we can see exactly what we're doing now. Okay, now if you took that .config file that you had, if you had one, and you copied it somewhere else, now you can copy it back to the Linux 2.4 directory, okay, and make sure it's called .config when it comes back to this directory. All right. Now, if you'd never had a .config file, or if you just want to start from some classic or standard configuration file for your particular system, you can look in the configs directory under Linux 2.4, and in there are a bunch of sample configuration files for all sorts of systems. Okay. Now, for my system, I'm going to pick this one, the kernel 2.4.18.-athlon.config, because I've got the Athlon processor. So what I can do is I can copy this configuration file up to the Linux 2.4 directory and call it .config up there, and then that will be sort of a starting point for my configuration. You don't have to do this. You can start from a clean slate and just configure everything yourself. I think it's smart to at least have some sort of base configuration so some of the basic decisions are taken care of for you. Okay, so what I'm going to do is I'm going to copy configs kernel.athlon.config and copy that up to the .config file. Okay, so I do that, I do an ls-a on my current directory, and now you can see the .config files there. Okay, so now I've got my base configuration that I'm starting from, and now to do the remainder of the configuration that I want to do to customize my kernel. So by customizing my kernel, what I'm saying is I'm deciding what things are included in my kernel, what things are included as modules, and so on. Okay, there's three options to do this customization. One option is you can just say make config. Now, make config is the least desirable of these three options, and the reason is because make config, what it does is it's a text-based interface, but not only is it a text-based interface, it's sort of a serial interface or a linear interface, in that it's going to ask you a whole bunch of questions one after the other, like hundreds of questions perhaps, depending on how you answer the initial questions. So and then you answer yes or no to the questions. You can answer M for including something as a module, that sort of thing. Okay, but you can't go back and make changes to questions that you answered previously. So if you screw something up, then you have to start all over again and do it again. Okay. Another option instead of make config is called make menu config. Now, to do make menu config, it's basically going to be the same as the next option that we look at that we're actually going to use. It's like the difference between doing a Linux text-based installation and a Linux graphical installation. They both do the same things, but they have different interfaces. Okay, this menu config is still a text-based interface, and you can go back and make changes, unlike make config. But so you can use this if you like. To do this, though, you got to make sure you have two other packages on your system, and those packages are called ncurses4, and you can check for it by saying rpm-q ncurses4 *, and then the other one is ncurses-devel. Okay, so you check that one by saying rpm-q ncurses-devel-*. Okay, so you have to have those two packages on your system if you want to do the make menu config. All right. If you want to do this one, though, make xconfig, you just need the packages that I told you about at the very beginning. Okay. Namely, the special ones are the TK and the TCL, the TICL packages, which are scripting languages that the xconfig program here uses to let us configure the kernel. Okay, so this is the one that we're going to use to do the configuration. And if you look in the Red Hat manuals, this is the one that they suggest that you use to do the configuration. So I'm just going to stick with their suggestion. I'm going to assume that they know more than I do, okay? And I'm going to obey their suggestion there. So I'm going to hit enter here, and now we get into the make xconfig screen. You'll see a window pop up here, and it's going to have all the various subjects or categories that we can configure our computer into, okay, that we can configure for our kernel. And there's the window. All right, now let's look at some of these headings here and look at the kinds of things that we can configure in our Linux kernel. And I'm not going to go through every single one of these menu items, and I'm not going to go through all the various sub-menus under these headings and so on, because we'd be here for like 5 videos talking about this stuff. And it's not that critical. I mean, if there's some particular thing that you're looking for, look on the internet, see where you would configure it, and then go ahead in there and configure that particular thing. The nice thing is, if you want to browse around here to see what all these things are, most of these headings, when you click on the button, underneath there has a pretty good help screen explaining to you what the various modules are that you're deciding about, whether you're including them or excluding them and so on. Okay, let's look at, like I said, the most important ones. The first one here is code maturity level options. Now that one, when we click on that box, we get this window popping up, and now we can choose whether we want to yes include or no not include developmental or incomplete code and drivers for our system. So what this is saying is, do you want to be asked about drivers or code that is not deemed stable yet? It's in the development stage, or it's in an incomplete stage. It's not tested yet, that sort of thing. Okay. Normally here you would say no. All right, and that's what I'm going to say. You would only say yes is if the only reasons you would say yes is if you were on, you were actually doing development of the kernel, and you needed to, look at some of the stuff that other people have written, and you're going to try to fix it or help them out and to test it or whatever. Okay. The other reason you might say yes is because you've got some brand new hardware device that doesn't have a stable driver yet, and so you need to have this developmental driver on your system so that you can try out your brand new hardware device. Okay, that's the sort of reasons you would say yes. Otherwise, you should just say no. And like I said, there's these help screens under each of these options, and you can click on help, and you get a pretty detailed explanation of what answering yes and no, the ramifications of answering yes and no. Okay, and you can see the summary down here. It says, unless you intend to help test and develop a feature or a driver that falls into this category, or you have a situation that requires using these features, you should probably just say no here. Okay, so we'll just say no, and we'll go back to the main menu, and then we'll look at loadable module support. Now this one has to do with enabling loadable module support, the kernel module loader, and so on. This is all about having a modular kernel. Okay, if you say no to all of these things and you're not enabling loadable module support and you don't want a kernel module loader, then you're basically going to build a monolithic kernel. Okay, feel free to build a monolithic kernel. Nothing's going to be wrong, but a modular kernel is going to perform better because it's going to eat up less resources on the system, like memory and so on. Okay, so I'm going to leave all those checked as yes. That's important. Alright, so processor type and features is where you can set very low-level specifications for your processor, low-level kernel modules. General setup, you can go in there and look around and see what's in there. It is what it says, general setup for the kernel modules. Binary emulation of other systems. This has to do with whether you want to be able to run binary code from other sorts of systems. So do I want to run binaries from like Spark stations or something like that? Then I could set that up under this particular heading here. Going down, parallel port support, pretty obvious what that is. You're configuring modules for your parallel ports on your system. Parallel ports, typically you plug in printers to there. You can plug in disk drives, things like that. Okay. Then multi-device support like RAID and LVM. If you're going to set up RAID array of disks or logical volume managers, then there are kernel modules in there to support that. Networking options, all the various network cards and network drivers and so on, you can configure that in there. ATA IDE support for other kinds of disk drives other than SCSI disks. So even though the primary, let me click on that one. Even though the primary disk on my system is a SCSI disk, I would still say yes here that I want to include support for these other kinds of disks like IDE disks because in the future I might add another disk to my system and then I can add an IDE disk and I'll have the support already there to build in. When you go to configure your kernel, make sure that you think a little bit ahead here. Okay, don't configure a kernel that is specific to your system as it stands now. All right, because you might add on other hardware, things like that, and so you want to make sure you have some flexibility in the kernel. All right. We go down here. There's amateur radio support. You can set up your Linux computer to interact with amateur radios. Okay, so if you're going to do that, but again, that's a very specific option and one that 99.9% of the people that use Linux do not need to worry about. Okay, infrared support for infrared networking, like wireless networking. Okay, there's support in there for that. Old CD-ROM drivers. If you don't have a SCSI or an IDE CD-ROM drive, if you have something older, then you have to get drivers from these modules. Make sure they're loaded. Okay, and so on. You can go down here, and like I said, most of these make sense, and most of these, the heading tells you what they're about, and most of them have good help files underneath of them, so you can see exactly what the ramifications of your decision are. Okay, when you get through configuring all of these things, then make sure you come over here and say save and exit. Okay, and now it's saying the end of Linux kernel configuration. Check the top level makefile for additional configuration. Next, you must run the make dep command. Okay, so we're going to say okay, and now we're back to our prompt, and now what we're going to do is move on and issue that make dep command like they just told us. Alright, so we've saved our configuration, and now there's a new .config file in our Linux 2.4 directory here that encompasses all of the changes that we made using make xconfig. Okay, now like that suggestion said, now we have to run the make dep command. And the make dep command is going to check for dependency information. Okay, so we've got to make sure all the dependencies are set up correctly, so that's what this is going to do for us. Alright, so it's going to go through, tell us what it's running, and all of this output is not necessary to go through line by line. If you want to capture all of this and see what it says, you can pipe all this stuff out to a file and capture it all if you want to see it line by line and see what's going on. Most of the time I just let this run, and then if there's errors, you can always go back and execute these commands again and pause the screen or pipe the output to a file so that you can see exactly what's going on. I'm just going to pause the video until this dependency information is all done. Okay, so now that make dep has run and all the dependencies are set correctly, the next thing we do is we issue the make clean command. And now this will prepare the source tree for the actual compilation. Alright, so I'm going to issue make clean, and then again a bunch of stuff's going to scroll down the screen, and things are removed that are not necessary for the process of for building out of the source tree here. Okay, now that we've done that, now what we want to do is we want to talk about just a special sort of customization that you can do to the name of the kernel file that you create. So if we look at, in this directory here, if we look at the make file, the actual script that has all of these various options for make in it, if we print that out to the screen, and I'm going to pipe that through the more command so it doesn't all scroll by, you can see here this extra version information. And the extra version right now, let's just look at this whole thing, like 2.4.18-14. Okay, that's the kernel that we're building. But notice it appends a custom onto the end, so that then when we create this custom kernel, we'll be able to distinguish it from our original kernel. The same reason before in the last video when we went to install the new kernel, we did an install and not an upgrade, so we still had the old kernel around. The same thing is true here. We don't want to customize a kernel and then delete the kernel that we knew was working perfectly well. Okay, so what we're going to do here is we're going to have this custom tag after that. You can go in and edit this make file if you want and change that. You can put your initials there, you can put the date that you're creating this, whatever. Some unique tag on the end to make this kernel have a different name than the original kernel that we're customizing. Okay, so I'm going to quit out of here, and now the next step is going to be another make command, make bz image. So we say make bz capital I MAGE. So make bz image, and now we're actually building the actual kernel now. So I'm going to do this, and this is going to take a while. I'm just going to pause the video while this is executing, and then I'll come back when that's done. Alright, so then once make bz image is done, then we execute make modules to make the modules that we configured. And now this screen is going to go on for a little bit, and then once that's done, then we will install the kernel modules with the command make modules install. Alright, so I'm going to pause the video again, and we'll come back once make modules is finished. Then the next step is we run make modules install, and this is actually installing the kernel modules. Even if you didn't build any, you still run this command. Okay, just to give you an idea here, the amount of time that's elapsing that I'm pausing on the video varies from processor to processor. Depends how fast your processor is, how much memory you have. Compiling is a pretty computationally intensive process, and there's a lot of work to be done, a lot of files to be operated on, and so on. So I can't give you an estimate and say, okay, it's going to take 15 minutes on your machine or 30 minutes or whatever. It's somewhere in that range. Certainly if you're using an old machine like an actual 386 processor, some of these compilations could take an hour or more to accomplish. Alright, so I'm going to hit make modules install now. Again, pausing the video until this is finished, and then we'll come back and we're almost done. Okay, and now we run make install. That last one, make modules install, was pretty fast. That was only like 2 or 3 minutes. And now make install will copy the new kernel and all the associated files to the correct directories. Okay, so in addition to installing the kernel files in the boot directory, this command also runs a couple scripts that build the initial RAM disk image and things like that. Okay, so again, I'm going to hit enter and pause the video and come back when that's all finished. Alright, well, we did it. That's all the commands that we have to execute in order to customize and compile and install our kernel from source code. If we do a listing of the /boot directory, in this directory you're going to see the new kernel right here, 2.4.18-14, the same version as the last one, but it's got that custom tag on the end. And remember, that custom tag comes from the make file in user source Linux-2.4. That comes from that make file, and it was set to be custom, and you could make it whatever you want, your initials or a date or something like that. Notice the initial RAM disk image is also there with that custom tag on it, as well as the system map. Okay, so that's what we have to do. Again, if we look at the etc grub.conf file, there's going to be a new stanza in the grub.conf file, and again, that was make install and the scripts that make install ran that put this stuff here. Okay, and it put the new kernel in there, 2.4.18-14 custom, and notice again the default stanza the default thing that boots is stanza 1, which is really the second stanza, which was the original kernel. Okay, so just like before, we've got two kernels in place. We've got this custom kernel and we've got the old kernel. So if we shut down our system now and restarted our system and we got to that grub screen, we would have two choices of kernels to boot, either the custom kernel or the old kernel. And so anything that we did in this, if we did something incorrect that causes a problem with software or various hardware on our system, we can always shut down and come back into the 2.4.18-14 kernel, the original one. All right. Well, good job on compiling the kernel from source code. It takes a while. It takes some patience and some care to make sure that you're doing everything correctly. But if you follow the steps here, you should have no problem getting it done. All right, well, it's time to wrap up our second nugget on the Linux kernel. And in this nugget, we went over the required tools so that we can customize and compile the Linux kernel from source code. I gave you that whole list at the beginning on the whiteboard of the GNU C compiler and the C preprocessor and the Tickle, the scripting language and things like that. All those things have to be installed to follow along and actually execute what I did in this nugget. Okay, and then just as a summary, the steps to compile and install. First, we did make mr proper to clean up the directory tree. Make xconfig was the tool that we used for customizing. Then make dep made the dependency information. Make clean cleaned up the directory before the actual build process. Make bz image was actually building the kernel. Make modules is what we used to build the modules that we configured. And then make modules install actually installed the kernel modules. And finally, make install is what copied the new kernel and the associated files to the correct place, and then it also ran a couple scripts that created the initial RAM disk image and altered grub.conf. Okay? If you run into problems with this process, refer to, I think it's Appendix A of the Red Hat 8.0 manual. If you're using Red Hat 9, look in the appendix of that manual for under building a custom kernel. And you'll see the same steps they follow there, and they also give some ideas on how to go about troubleshooting problems if you have them during this process. All right, well, I hope you found this nugget informative, and thanks again for watching.